In the last episodes, we explored Python's basic data types like numbers, strings, and booleans. Today, we're going to unlock a new tool, variables. These help us reuse data, stay organized, and work more efficiently in our code. So far, we've learned how to create objects in Python and print them right away. But in real programs, we usually want to store those objects and reuse them. That's where variables come in. In Python, a variable lets you assign a name to an object, so you can refer to that value later in your code. A common way people explain variables is with the box analogy. Imagine a box that holds a value, and the variable is the label on the box. But honestly, that idea can be a little misleading when it comes to Python. Why? Because in Python, variables are more like names that point to objects, not boxes that contain them. It's kind of like calling your couch a sofa or a love seat. Different words, same piece of furniture. The object doesn't change, just the label you're using to refer to it. Let's see how this works in practice. Here's a simple example. Set greeting equal to hello. Now greeting is a name pointing to the string hello. You can also give multiple names to the same object. For example, set A equal to 42, then set B equal to A. Now, both A and B point to the same value. You didn't make a copy, you just gave it another name. It's like calling your friend Alex at school and Lex at home. Same person, just different names. Now let's look at an example of reassignment. Set X equal to 10, set Y equal to X, then change X to 20. Finally, print Y. What gets printed? The answer is 10. Why? Because Y kept the original value. When we changed X, we didn't modify the number 10, we simply pointed X to a new number. The name X was reused to point to a different object. Let's pause here to highlight something important, a theme you'll see throughout this course, code reusability. Code reuse means writing code in a way that lets you use it again, either in different parts of the same program or even across completely different programs. It makes your work more efficient, reduces repetition, and makes your code easier to maintain and debug. If we don't reuse what we already have, our code starts to pile up. It gets bloated, messy, and full of clutter we don't need. Let's take a look at a few examples to see how variables actually work in Python. Set name equal to Anne, then print hello plus the value of name. Next, print the value of name plus the phrase, how are you today? Here, we created a variable called name and gave it the value Anne. Then we use that same variable in multiple print statements. This is a simple example of code reuse, using a single value in more than one place without repeating yourself. Here's one more example. Set value 1 to 101, set value 2 to 42. Then print value 1 plus value 2. This gives 143. Next, reassign value 1 to 0, then print value 1. Now it shows 0. This shows that you can reassign variables. We updated value 1 to 0 after using it in a calculation. Now, a quick note about the print function. When you pass multiple arguments to print, separated by commas, Python automatically adds spaces between them in the output. This works differently from using the plus sign, which joins values directly and requires them to be strings. It also doesn't add any spaces unless you include them yourself. For example, print hello world, the output is hello world. Print hello plus world, the output is hello world with no space between the words. Python also lets you assign multiple variables at once in a single line. Each variable gets its value in the same order you write them. For example, set x and y equal to 1 and 2. Then print x and y before swap, followed by the values of x and y. Now swap them by writing x, y equals y, x. Then print x and y after swap, followed by the new values. This is a neat Python trick. You can swap the values of two variables in a single line. No need for a temporary variable, just x, y equals y, x, clean and Pythonic. Here are the rules for naming variables in Python. A variable name must start with a letter from A to Z or with an underscore. It cannot start with a number. It can only include letters, numbers, and underscores. That means lowercase and uppercase letters, digits 0 through 9, and the underscore character. Variable names are case sensitive, so age, and age are all different. You cannot use Python keywords as variable names like if, for, or class. There's a full list of reserved words in the video description. Here are some examples: valid variable names, user_name, total amount, and hidden value. Invalid names, too cool because it starts with a number username because it contains a hyphen, and class because it's a reserved keyword in Python. Last time we talked about 3 basic built-in Python data types: int, float, and str. Today we'll learn how to convert values from one type to another, a process called type conversion. Let's say you have 2 strings, 4 and 2. If you use the plus sign between them, print 4 plus 2. The output is 42. This combines 2 strings into one. It doesn't do any math, it's just text concatenation. But what if you want to add those values as numbers? That's where type conversion comes in. To convert an int, that is, an integer, to a float, use the float function. For example, set count equal to 5. Print count equals followed by count. Then set count as float equal to float of count. This converts the integer 5 to the floating point number 5.0. To convert a float to an int, use the int function. This removes the decimal part. It does not round. For example, set temperature equal to 3.14. Print temperature equals followed by temperature. Then set rounded down temp equal to int of temperature. This takes the float 3.14 and converts it to the integer 3 by simply dropping the decimal. To convert a str, meaning a string, to a number, you can use the int or float functions. For example, set age string to the text 42, then set age int to int of age string, and set age float to float of age string. Print age int equals followed by age int. Print age float equals followed by age float. The string 42 is converted to the integer 42 and the float 42.0. But if the string doesn't represent a valid number, you'll get an error. For example, set invalid input to the text XYZ, then try converting it with age equals int of invalid input. This will raise a value error. That's because XYZ is not a number and can't be converted. To convert an int or a float to a str, use the str function. For example, set score to 98, set average to 76.5, then set score string to str of score. Set average string to str of average. Print score string equals, followed by score string. Print average string equals, followed by average string. Now the integer 98 and the float 76.5 are stored as strings, but just by looking at the output, it's not always clear that a value was converted. To confirm the data type of a variable in Python, you can use the built-in type function. The type function is a built-in tool in Python that returns the data type of an object. You give it any variable or value, and it tells you what kind of object it is, like int, float, or str. Let's use it to check the types of our converted values. Print type of score string. Print type of average string. These calls to type confirm that both score string and average string are now of type class str. You can use the type function anytime you want to inspect a variable and understand what kind of data it holds. This is especially helpful when debugging or learning how Python handles different kinds of objects. Today, you learned how variables work, how to name them properly, and how to convert between different data types using Python's built-in functions. Thanks for watching. Don't forget to subscribe and hit the bell icon so you don't miss the next lesson. And if you'd like to support the channel, there's a Buy Me a Coffee link in the description. Totally optional, but always appreciated.